Okay, now that we are done graphing, we can move forward to some of the things that we actually did first when we started this chapter, which involve multiplying, dividing, adding, and subtracting these rational expressions. So when we are dividing, we always want to factor first. So I see x squared minus 4. I'm going to change that into x plus 2 and x minus 2. My denominator on the left cannot change. But on the right, x squared plus 4x plus 3, x plus 3, and x plus 1. My denominator on the right, I can take out a GCF of 2, and I get x minus 2. Now I look for things that I can cancel out. So I've got these x minus 2's, those are gone. I've got x plus 3, those are gone. And then it looks like that's all we're going to be able to cancel, which is still not bad. And we are left with this x plus 2, this x plus 1, and the 2 in the denominator. So my final answer, I leave it in factored form. Why bother foiling it when you could make a mistake? So I have x plus 2, x plus 1 over 2. Now, I'd like to be able to say, ooh, 2 over 2, cross those out. But I cannot, because the 2 on top is being added to something else. You can only ever cancel when you're multiplying. So this is, in fact, our final answer. Now in number 17, we are dividing, so the first thing I would do is say, you know what, copy dot flip. So I have 4x minus 8 over x squared minus 3x plus 2 times x minus 1 over 3x minus 6. And then sometimes I do it simultaneously. Notice I tried when I threw in those parentheses. But next we're going to factor. So numerator on the left, 4x minus 8, take out a GCF of 4. We're left with x minus 2. Denominator on the left becomes x minus 2, x minus 1. Numerator on the right, staying. Denominator on the right, take out a GCF of 3. You're left with x minus 2. Cancel everything you can. X minus 2, x minus 2, x minus 1 on the top right and the bottom left. And then it looks like all we are left with, we've got this 4 on top, the 3 on bottom, and then the x minus 2 on bottom. So again, leave it in factored form. Why not? 4 over 3 times x minus 2. Final answer. Now, number 19, we start adding our rational expressions. When that's the case, we need to think about a least common denominator, an LCD. Our least common denominator involves all pieces from all denominators. So I've got a 6x and I've got an 18x. Well, I know I'm going to have an x. And then I've got a 6 and an 18. The LCD, if I had 1 6 plus 1 over 18, would just be 18. Now, don't get this process confused with if I had this like equal to 1. We'd multiply everything by our LCD and get rid of all of our denominators, right? That is not what we do when we just straight up add them. What we do is we think about what we need in order to get that least common denominator. Well, our first fraction is fine. It has the least common denominator. Our fraction on the left, what do I need to make that 6x and 18x? Oh, I just need a 3. So then I have 15 over 18x plus 7 over 18x. And we would say, oh, look at that fraction on the left. We can reduce that. Well, yeah, but that's going to take us to where we started. So we don't want to do that. But what we can do now that we couldn't before is just add straight across the top. So I have 22 over 18x, but of course I would want to reduce that as much as possible. The 22 and the 18 are both divisible by 2. So I say divide by 2, divide by 2. I have 11 over 9x. Final answer. Number 21, I am doing the same thing. I'm looking for what my least common denominator might be. Well, in order to find that out, I should first factor that denominator on the left. Two numbers that multiply to 21 and add to 10, 7 and 3. My signs are the same. They are both minus. Now we can see that that x minus 3 piece overlaps, and I just need to consider that extra piece as well of that x minus 7. So my LCD is that x minus 3 and the additional x minus 7. My fraction on the left is perfectly fine the way it is. It has the least common denominator it needs to have. So it will stay 3x over my LCD, which I'm too lazy to write out, plus my second fraction. The piece that is missing is that x minus 7. Notice I automatically put it in parentheses. I need to distribute that 5x minus 35 over my LCD so that I can combine like terms. So I'll go ahead and take the time, write out that least common denominator. X minus 3x minus 7. And on top we combine like terms. 3x and 5x gives us 8x. And then that minus 35 comes along for the ride. Final answer.